Number 2 is asking, is it possible if 3 points are coplanar, then they are also collinear? Justify your answer. So possible if 3 points are coplanar, then they are collinear. So when we look at this problem here, we have to define two things here. We're defining the term coplanar, and we have to define the term collinear, right? So the term coplanar basically means that they belong to the same plane, or the points or the set of points belong to the same plane. So it belongs to the same plane here. And then finally, collinear. So collinear just means that it follows a formula, follows a set formula for, like, you can think of it as a equation of a line. It follows a constant kind of increase here. So again, for example, this graph here would be collinear because all the points lie on that line. So I'll say belongs to the same line here. Belongs to the same line, or you can say linear function. Okay, so it says describe if 2 points are coplanar, then they are also collinear. So let's draw an example here, and I'll draw 2 examples here. Use the line tool just to make it a little bit more easier. So I have so I'm gonna have one line here first. So I have one line here. So for example, if these 3 points here, if 1, 2, and 3 here, and the coordinates don't really matter, but in this case here, my 3 points here are coplanar. Basically, anything I put in this xy plane here will be coplanar because they belong in the xy plane, right? So immediately, these points here are coplanar. However, they're also collinear as well because, as you can see, all these points lie on the same line. So they are also collinear. However, what if I had something like this? What if I had something like this? And what if I had something like this? Like if I had this graph like that. This is still coplanar, right? These guys here are still coplanar. So still coplanar. However, these are not collinear now, right? Because they don't belong to the same line or function, right? As you can see here, I have 1 point here, 1 point here, and 1 point here. I can't make a linear function. It's not like a slope that's a constant slope, right? In this case, it's a quadratic function here. So this point would be not collinear. So therefore, we can say that is it possible that if 3 points are coplanar, then they are also collinear? It is possible. So in this case, it is possible, but not always the case. So our answer here is that. So is possible if 3 points belong to the line, the linear function. Not possible besides that part. Not possible besides that. So that's kind of our answer here. So in this case, they wrote the exact same thing. It says, in this example, points are collinear, so they belong to the same plane, which is good, and they're also collinear because we can join them with a straight line. They belong to the linear function. This is like my first guy here. And then in this case here, they made a triangle here. It says points here are also coplanar, right? They belong in the xy plane, but again, they're not. This is not a linear function here. I can't throw one straight line and go through all of these 3 points in one smooth line here. So as you can see, this here would be coplanar, but not collinear here. So this solution here is correct. Solution is correct. good use of examples here.